Hi, second grade parents. My name is Marissa Benjamin. I am the math coach at Rocky Ridge. And first of all, on behalf of all of the teachers at Rocky Ridge, we would just want to say thank you for working with your kids and for doing everything you can to help continue this educational process. This is new, uncharted territory for all of us. So we are just all trying to figure it out. And I know that you have had much grace with us, and we are so thankful for that. But we know that doing math at home, when you were not taught the way that we are teaching your kids, can be difficult and frustrating. I've seen a lot of the memes that go around on social media. So in order to support you, the second grade teachers thought it would be a good idea if we made just a quick video for you about some of the strategies for addition and then some of the strategies that we use for subtraction. So this video is about addition strategies, and then there will be a second video with subtraction strategies in it. I'm going to, for the purpose of our conversation, use one addition problem and show you the different strategies using the same addition problem. However, the idea of students understanding multiple strategies is that when they look at an addition problem, they can determine which strategy is best used for this problem. So that's what we call a flexible thinker. So, so the reason that we kind of promote multiple strategies is not because we think kids need to memorize a million different ways to do something. It's that we want them to understand that sometimes when you're in the grocery store, it's easier to do a strategy in your head because the numbers lend themselves to a particular strategy. So in this case, like I said, I'm going to use one problem. So I'm not really going to highlight that, but I will talk to you hopefully a little bit about each strategy and what kinds of numbers might lend themselves to that. Or maybe you could be thinking about that while we're looking at the problem. So the problem that we're going to do today is 276 plus 349. So I'm going to show you a couple different strategies. The strategies that we talk about in second grade are adding using the place value. We're going to talk about keeping one number whole. We're going to talk about using a number line. And we're going to talk about compensation. So these are the main strategies that you would see your students using. And I had something else I was going to say, but I forgot, but I'm sure it'll come back to me, so that'll be fun. Okay, so we are going to get started with adding with place value. And we start with this as a good strategy. This is not a strategy that necessarily we are going to continue to push. We'll kind of phase kids out from this strategy and push them into keeping one number whole. This one's a little bit simpler for kids to understand. This requires kids to be able to hold information in their head a little bit more. I do want you to know, this is what I was going to say, I do want you to know that the U.S. traditional algorithm does come. It's a fourth grade standard. So the writers of the Common Core determined the developmental appropriateness of the algorithm because the algorithm, we all learned this way, right? We would say 6 plus 9 is 15, and we would put a 5 here and carry a 1. But it's really, inside of 15, that 1 is a 1 in the tens place, and we call it a 10, and we would really be carrying a 10. And so it loses sight of place value. And so that's why we have pushed it back, because right now in second grade, we're really trying to build a firm understanding of place value of 3-digit numbers so that in fourth grade, they can just add using the algorithm should they need to. So please know that we are not against carrying the 1 or anything like that, but we want kids to have a foundational understanding, a conceptual understanding of place value before we ask them to do something that sort of ends up being kind of if they don't have a foundational understanding, it's a trick. But we all know it's not a trick. There's reason behind it, but we have to understand the place value first. So. All right, so to add 276 plus 349 using place value, it's thinking about each part of these numbers, right? So this is a 200 plus a 70 plus a 6. So it would be thinking about it basically in standard in its expanded form, okay? And 300 plus 40 plus 9. And so we would think of it like this: 15, 40 plus 70 is going to be 110, and 200 plus 300 is 500. And so now we can think about this problem: 500 plus 110 plus 15, and eventually we would like kids to just be able to know those two numbers together, and that those two numbers together are going to give us 625. All right, if you have questions along the way, obviously this is not a live video, so feel free to email me or to email your child's teacher. My email address is mbenjamin, BENJAMIN, @hoover.k12.al.us, and I'm happy to either I can have a live conversation with you should we need to, phone call or whatever. I'm happy to help. All right, we're going to try keeping one number whole this time. So again, we're thinking about this problem, plus 349. And this strategy actually couples beautifully with a number line. So I'm actually going to show you using a number line as a model for this strategy. But we can also just use the mathematics for this strategy as well. So if this is our number line, and we're going to think about 276 plus 349, I would prefer to break apart 276. So I'm actually going to think about starting at 349 on my number line, and then I'm going to add 276 in its place value part. So I'm going to add 200, and then I'm going to add 70, and then I'm going to add 6. So to 349, if I were to add 200, that would be a pretty big jump, right? 349 plus 200 is 549. Okay, then I need to add 70. So now I'm going to struggle a little bit because adding 70 to this number is going to cause me to cross over another, we call it rounding a corner. So we're going to cross over past 500s into 600s. So I'm going to chunk this a little bit more, and I'm actually going to add 50 and 20 instead of 70 altogether. So 549 plus 50, and I am trying to make my jumps fairly proportional, but I have this teeny tiny whiteboard at home, so I'm doing my best. But 549 plus 50 is 599. Now I'm like, oh yeah, I know this number, okay? So now I can add 20, and that's going to put me at, let me think, 599, 609, 619. Whoops, my video stopped. So we were here. We started at 349. We added 200 to get to 549. We added 70. That got us to 619. And now we need to add 6 more. So you can just add 6, or some kids might say, well, I'm going to add a 1 to get me to 620, and then a 5 to get me to 625, because I know inside of a 6 is a 1 and a 5. So that's keeping one number whole, and then chunking the other number. You could chunk by, there's no formula to what a kid has to chunk by, but we do encourage them to chunk by at least place value to make those larger jumps. But again, inside of 70, I felt more comfortable with a 50 and a 20. Some kids might feel more comfortable with 10, 10, 10, 10, 10, 7 times. So that's why we use the number line with that, along with that, but that in the same way could look like this: 349 plus 200 is 549. Okay, now we're not going to come right underneath here and write another problem, because that would be a misuse of the equal sign. So now we're thinking about 549, and then we're going to add 70, right? And so here I'm thinking about 54 tens plus 7 more tens, or 4 tens and 7 tens, which is 11 tens, right? So, but I think about it as 54 tens plus 7 more tens is going to go, follow me here, 54 plus 7 is 61 tens. There's that. And then we would have 619 plus 6, which gives us 625. Okay? All right, so a lot of that I have to do mentally when I'm just writing the mathematics. So we always encourage kids, especially in the second grade, to draw this model, this numerical model or physical model, to go with keeping one number whole. So that's the number line too. The number line also, you could have started at 276 and added 340 and 9. Here's another way that kids like to use a number line, since we have this beautiful problem that I am going to show you. If, let's say, they did want to start at 276, which is absolutely fine, okay, and they're like, you know what, I know something about well, first of all, they say, I'm going to add 300, right? That's 576. And then they say, now I have to add 49, but I know something about 49. It's really close to 50. It's only one extra. Then they might do something like this and go plus 50. Okay, and kids oftentimes know about quarters. So they're thinking about, this is 2 quarters, right? So if I have $5.75, just rounding, and 2 more quarters, that's going to get me to $6.25 because I get to 600 and then to 25. But remember, we've added 50 instead of 49 here, so we get to 626, and then we just can take away 1, and that gives us our final answer of 625 because I went 1 extra here, okay? Okay, and our last strategy that we're going to talk about is compensation. And again, this is not a problem that I would necessarily see, especially second graders, actually compensating on, but I'm going to show you what compensation is, and I'm actually going to show you a problem where you might see them compensate. So for the sake of what we're doing, we're solving this problem, right? And so compensation is what we call give 1, take 1. Or it could be give 10, take 10, or give 25, take 25. But in give 1, take 1, we're basically trying to get a friendlier problem than what we have currently. So right now we don't really have very friendly numbers, but students might be able to tell, again, because they know about quarters, they might be able to think about this number and see the 76 and the 49 and think, I could take 24 from here and give it to here. If I take 24 from this number and give it to this number, I now have 300 on the top. And if I take 24 away from 349, I have 325, right? Because 24 is almost 25, and 349 is almost 350. So that's how a kid is thinking, and kids do this. And now this is a very easy problem for me to solve. Again, I'm not going to see a second grader using this kind of compensation on a 3-digit problem, but they might do it on a problem like this, right? Because 19, super close to 20. Take 1 from here, and now I have 20 plus 27. All right, so just some quick background about compensation and why it works. It's going to come from thinking about it on a number line, okay? And it's going to come from thinking about, we are thinking about, I'm trying to think which number we changed, 276, right? And we were thinking about adding 349, and but we are going to say, here's 349, and this is where we're landing. Okay, that's where our answer is going to be, right? However, if we are going to adjust to add, we adjusted the problem now to be 300 plus 25. All of this, I'm not going to use my number line because I'm confusing myself with it. This happens as teachers. But what I want you to know is that all of this adjusts because this is still all the same, right? We just took some from down here and gave it to up here. So it would actually be better if I had all of these manipulatives out, but I'm not counting out 276 manipulatives and 349 manipulatives. I'm just going to need you to use your brain and think about if I had 276 in this group and 349 in this group, right? And so if I have that and I take some from one group, over here, right, the 349 group, and pull it over here to this first group, have I changed the number of manipulatives that I have out on my table? No. All I did was move them from one group to the other. So that's why this is called compensation, and that's why it works. So again, back to our problem we might see a second grader compensate on, right? If I have 19 things in one group and 28 things in another group, and I take one from the 28 group and make it a 27 group, and I don't take it off the table, I just put it in the other group, right? I haven't adjusted how many things are on the table. I've simply adjusted how many blue things and how many red things I have, if that makes sense. So again, I apologize. Sometimes I start thinking in one way and then my brain takes me in another way. So again, the number line is there, but it's clearer when you think about it in manipulatives. So if you have questions, please feel free to get in touch with me or your child's teacher. I'm happy to help you, and I will call you on the phone if you need a phone call. I will help you in any way that I can. Hey parents, this is what it's going to be like. E-learning is, Ms. Benjamin just remembered I didn't share one of the other strategies with you that is probably going to come up at some point. So thinking about our problem 276 plus 349, we would call this partial sums. And this strategy that I'm going to show you is actually what we think about leads into the algorithm. And you can kind of see that. You'll be able to kind of see that as we go. So partial sums is going to think about each part of the problem, much like adding with place value did, but we are going to keep it up and down like this, and I'm going to show you where you see the partial sums. So for instance, we're going to add the ones place, 6 plus 9, and that's 15. So instead of writing a 5 and carrying the 1, which is what you would do, we're going to write the whole number that we just came up with, 15. Then we have 70 plus 40, and thinking about that, rather than carrying again, we're thinking about 70 plus 40 is 110. And then 200 plus 300 is 500. Now, some people might do this backwards, and they might start adding from left to right. It would give you the same products, same partial sums, not products, same sums, but you would have 500 up top and 15 at the bottom. So that would be that flipped. So then partial sums looks like this. Now we can add this, 5 plus 0, which is 5. 1 plus 0 is 1, and 1 plus 5 is 6. Oopsies, I forgot this 1. 2 plus 0. Okay, but you get the idea that it's just rewriting the sums rather than carrying. So you have less opportunity, but you notice what I did. I made a mistake, and I made that mistake on purpose. But because I didn't exactly line up my place value, so I made that little mistake, and I sort of forgot off this 1, especially when I'm looking at this upside down. So you always want to make sure that you are looking back into this. This is not a misuse of the equal sign when you do it like this, because the fact of the matter is 276 plus 349 is 625. So it's like saying 276 plus 349 equals 115 plus 110 plus 500 equals 625. So that's just my side note. But there is partial sums.